Hey guys, so today we're going to go over finding the volume of the prisms. Last week we worked on finding the surface area of each of these prisms. So today we're going to go over rectangular prisms, triangular prisms, and then we'll also do something called a trapezoidal prism. I'm assuming that would be a trapezoid. So volume might be a little bit quicker just because of finding the space that fills in. Now, before we really move on, the volume is how much something can hold on the inside. Okay, surface area is more of the outside. That you had to figure out, you had to find the area of each of these faces, and then you had to add them together because you figure out that there are 6 faces to the prism. Well, the volume, all you need to know is this formula right here. Now, I know I'm not wanting to make you guys memorize a bunch of formulas, but if you think about it, if I were to fill up this prism with water or anything like that, the volume tells me that I just need to find the area of the base, which in this case would be a square or a rectangle, and then I need to figure out how tall it is. Because if I'm going to fill up this entire prism with stuff or air or liquid or whatever amount, I really need just to figure out how much the base, how big the base is, the area of the base in that case, and how tall it is. Because the bigger the base, the taller it is, the more it's going to hold. The smaller the base, the shorter it is, the less it's going to hold. So based on that, to find the area of any prism, all you need to know is that you need to find the area of the base, whatever shape the base is, and you multiply the height. So let's figure out what bases and heights are. So bases in prisms are two identical ends, so to speak, and we name a prism by its base. So in this case, this would be a rectangular prism because the bases are rectangles. And then the height, so this is base 1, this is base 2 down here, and the height. The good way to figure out what the height is, the height's job, basically, if I'm how tall I am, the height connects the top to, in this case, the bottom. If you're standing up, the height for you would be the top of your head to your feet or to the ground. That's the difference, or the how long you are. In this case, the height connects the two bases. That way, even if we spin this prism like that, you can still see that the height never changes. The height's job is to connect your two-dimensional shapes. Without the height, really, you have two-dimensional shape. Height gives it something depth, which makes it three-dimensional. So this rectangular prism, you would just need to find the area of whatever the base is. In this case, it's a rectangle, length times width, and then times how tall it is. So let's jump right in. So I do want you guys to wish this, and I do want you to go slow, pause the video. If you already figure it out, go ahead and jump ahead and then check your work with us. So find the volume of this rectangular prism. So again, first thing I need to do is identify the bases. The bases, in this case, will be my two rectangles. I know that they are identical rectangles. So my volume says find the area of the base times how tall it is. The height will always connect to two bases, so in this case, the height is 10 centimeters because it's right here. It connects it. And then the area of my base, in this case, is a rectangle. So to find the area of my base, it's going to be length times width times height. Now, I know that you guys did a little bit of this in science, so that's awesome. So we're just continuing to do the same thing. So sorry, I shouldn't do B there. It should be volume. So this right here represents the area of my prism that I have right now. Now, it isn't always going to be length times width. It depends on the shape of the base. Okay, if it's a square, we'll get that to next. You would do base times height divided by 2. If it's a trapezoid, and then you would use the area of that base formula. So from here, we just go 4 times 4. So the area of the base is going to be 16 centimeters squared. And then the height is already 10, so I'm going to multiply this by 10, okay, to get 160. And this is the tricky part, centimeters cube. three-dimensional. You're multiplying 1, 2, 3 units, so that's why it's to the power of 3. So the volume of this is going to be 160 centimeters cubed. And that's how you would find the volume of a rectangular prism. In other words, length times width times height, or the area of the base times the height. Okay. Next, we have the volume of a triangular prism. So again, the volume is always going to be the area of the base. That's what this little AB means. A sub B means area of base. Okay, and H stands for height. So let's jump right in. Let's find the area of the base first. I notice first you need to find the base. This one luckily is triangular, hence the name triangular prism. So there is one triangle, and then the other triangle is going to be right there. And my height, like I said, connects my two bases. So in this case, my height would be 11. So let's go find the area of my base first. The area of my base is a triangle, so I know that the area of a triangle is equal to base times height divided by 2. And if I take this, multiplied by the height, that will give me the volume of this triangular prism. I'm just showing you algebraically what's happening here. So the volume of this would be base times height divided by 2 times the height of the actual prism, not this height of this triangle, to give you the volume of this triangular prism. Okay, so let's go ahead and do some quick math here. So the volume is equal to base times height of the triangle divided by 2 multiplied by the height. So let's find the triangle first. So the triangle, area of, sorry about that, area of triangle is equal to base height divided by 2, which is, in this case, the height is 5. You always look for the right angle because this is a right angle triangle prism. Okay, so it's going to be 5 times 4 divided by 2, which becomes 20 divided by 2, which is 10 centimeters. So there's the area of my triangle. And then now I go back and go, okay, so the volume is going to be 10 times how tall it is, which is 11. Okay, and my volume is going to be 110 centimeters cubed. And there's my answer. So finding volume is a little bit simpler than finding surface area. Finding volume is you need a first step. Step 1, identify the shape of the base. In this case, this is a triangle. You find the area of that base. And then you multiply by how tall it is, the height. Okay, last example for today. I'm going to find the area of this shape. And this one says find the volume of the prism by finding the base area first. I went ahead and highlighted it for you. I can quickly tell that I have one set of parallel lines and this is not parallel. So this is a trapezoid. So the volume is going to be the area of the base times how tall it is. So if I were to flip this on its side, I can tell that the height is 5 centimeters because here's my base right here, this trapezoid. So the other side would also be a trapezoid. So the definition of the height of a prism, it connects the two bases. So I know that my height is going to be 5 centimeters. Okay, that's the overall height of my prism, not the height of the trapezoid. Okay, now let's find the area of the trapezoid. If you remember, if you don't, look in your notes, we'll go over more. Area of a trapezoid is equal to base 1 plus base 2 times its height of the trapezoid, not the prism, divided by 2. So let's just, base 1 is going to be right here. So here's my B1, here's my B2. So B1 is 15, base 2 is 18. The height of my trapezoid is 7 centimeters. So this is where it might get a little bit confusing because you have the height of the trapezoid, and the last one you have the height of the triangle. So the height, the area of the base will be the height that's two-dimensional, not the three-dimensional height. We already determined that the three-dimensional height in this shape is the one that connects my two bases. So the area of a trapezoid is going to be 15 plus 18 times 7 divided by 2, and that's going to give me the area of my trapezoid, this trapezoid right here, and I'll write that in a little bit. Okay, so then I get 15 plus 18 is going to be 33 times 7 divided by 2. I'm going to quickly show you on the calculator what's going to happen if you put it all in at once, if it's all multiplying and dividing. So we got to be careful that you don't do something like this. 15 plus 18 times 7 divided by 2. Okay, I get 78. I think that's going to be right, but I'm not really sure. Now let's actually follow my orders of operation with the parentheses first. 15 plus 18 is 33 times 7, enter. 231 divided by 2. And there we go. See the difference? This one right here is wrong, incorrect, because orders operation tells me the calculator is what it's doing first is it's going to do 18 divided by 7, 18 times 7 divided by 2, and it's going to get a number. Okay, it's going to get some number, and then it's going to add 15 last. That is incorrect when it comes to doing the area of a trapezoid. You have to follow your blueprints. In this case, you have to do what's inside the parentheses first, and then you have to do everything on top of the numerator before you divide by 2. So the area of my trapezoid is going to be this one right here. 100, whoops. It's going to be 115.5 centimeters square. And now I just multiply this by 5, this height right here, to figure out how much space it can hold, times 5 centimeters. I'm just following the formula. So 115.5 times 5. The volume of this trapezoidal prism is going to be 577.5 centimeters cubed. Okay, so in review, first thing you do is find the area of the base, multiply by how tall it is, and that will give you the area of prisms, regular prisms. Okay, now be careful with the orders operations of finding the area of a trapezoid. Okay guys, that's all I have for today. Make sure you guys whisk this, rewatch it, and then we'll go over it in class. Thanks guys.